Today we're going to take a look at a few different types of matrices, and following that, this is the first thing that we will be doing, and following this we're going to look at a couple of more matrix operations. So let's get started with this. So we will be taking a look at four different types of matrices: the identity matrix, square matrix, a null matrix, and an idempotent matrix. So let's start with identity. Actually, let's start with square matrix. I have the ordering wrong actually. So I'm going to get rid of this and bring this up here. Take this down here and matrix. Okay, so let's start with square matrix. And square matrix is pretty simple. It just means that, I'll just write it down here. If you have a square matrix, what you have is that number of rows is equal to number of columns. So we have seen 4x4, 2x2 matrix already, where we had A11, A12, A21, and A22. This is a 2x2 matrix. So as you see, number of rows and number of columns is the same. And so you can have a 3x3 matrix, a 4x4 matrix, a 100x100 matrix. It's all square. Okay, so from there, let's go to identity matrix. And so first thing about an identity matrix is that, or I'll just write it here. First thing is that all identity matrices, I'll just write an I, all identity matrices are square. So an identity matrix must be a 2x2 matrix, or a 3x3 matrix, or a 4x4 matrix. So the notation for an identity matrix is basically IN. And this in tells us the dimension. So if we are talking about a 2x2 identity matrix, we are going to have I2. If we have a 3x3 identity matrix, we're going to have I3. And so what an I2 is simply this. Okay, so this is 0 in case that wasn't obvious. And what a 3x3 identity matrix is simply this. And so from here, you guys can understand what the pattern is, and you should be able to construct an identity matrix of any side, of any size, I4, I5, I6. So all we are going to have is that the principal diagonal is going to be 1, and everything else will be 0. So I'll just write this down. An identity matrix has all the elements, that's not it, elements on its principal diagonal equal to 1. All other elements is 0. So that's what we have. And just to show you guys another example, if we have an I4, I4 is a 4x4 matrix, and everything on the principal diagonal is 1, everything else is 0. So what we will have is 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. That's an I4 matrix, that's it. So what's so special about identity matrices? Why do we need to know about an identity matrix? So there are a few properties that an identity matrix has. What's happening here? I don't know what this is. Okay, so let's talk about some of the properties of, well, these are not really properties, these are more like features of identity matrix. One is that if we multiply an identity matrix with itself, we get the matrix itself. So if we have an IN and we multiply it with an IN, we are going to get IN. Or another way of writing it would be to say IN to the power M is N, where M is an integer. So no matter how many times we multiply an identity matrix with itself, we'll still get the same matrix. I'll give you guys an example. So we have I2, and let's multiply it with I2 again. So what do we have? 1, 0, 0, 1. 1, 0, 0, 1. So remember, whenever we're trying to do matrix multiplication, first thing to do, take a look at the dimensions. Make sure that they conform. So this and this are the same, so they do conform. What will be the dimension of the resulting matrix? 2 by 2. So, oh, sorry. What we are going to have is a 2 by 2 matrix. So this, this, and this. And how do we calculate them? Well, we've done it in the last lecture, so hopefully all of you remember. If you want to, you may pause the video, do the multiplication yourself. But effectively, what you get is 1 plus 0, 0 plus 0, 0 plus 0, 0 plus 1. So you end up with 1, 0, 0, 1, which is exactly equal to I2. So we multiplied I2 with itself and we got I2. And no matter how many times we do this, we will continue to get I2. Same is true for I3 and everything. So that's the first feature. Second feature is that if we have a matrix A, suppose, and we post multiply an identity matrix with A, or if we, pre-multiply identity matrix with A or post-multiply, we are going to get A. As long as, so this is important, which is that A and I should have the same dimension. So let's take a look at an example. Actually, let me rewrite this. A and I should conform. We'll see why that's important. So let's take an example. So suppose we have A, which is equal to, let's say, 7, 3, 2, 9. Okay. And so it should be obvious that what we are going to need is an I2. If we have an I3 or an I4 or an I5, none of them will conform with A. And then obviously we can't multiply. If we can't multiply, we don't have an IA or AI. So to conform, we take I, but now let's see if we have IA, what we have is 1001 times 7329. And if we have A1, AI, we have 7329 multiplied by 1001. And once again, if you guys want to, you can pause the video and do the multiplication yourself. But I'm just going to rush through it and not explain too much. I'm expecting you guys know how to do this. So what we get here is 7 plus 0. And here we get 3 plus 0, 0 plus 2, and 0 plus 9. So that gives us 7, 3, 2, 9, which is of course equals to A. And if we do this, what do we get? Same thing actually. We get 7 plus 0, we get 0 plus 3, we get 2 plus 0, and 0 plus 9. And ultimately we get the same thing, 7, 3, 2, 9, which is also A. So this relationship, as long as they conform. So I sort of rushed through the multiplications. Primarily, I'm doing this because, I mean, this is a video. I'm not, talking to you guys directly. So if I'm going too fast, just slow down the video or pause as many times as you want. Usually when I'm talking to students directly in class, I would have done this slower, but since this is just a video, I'll rush through it. Okay, so we've looked at two features. Why did I write one here? So this is the second one. And okay, that's it. So we've looked at square matrix. We've looked at identity matrix. Now let's come to null matrix. Okay, so null matrix is even simpler. What you have basically is, this is a null matrix. There's no restrictions on dimension. A null matrix can be of any dimension, but the requirement is that all of its elements are equal to 0. So effectively, the one feature of null matrix is if we pre-multiply or post-multiply anything with a null matrix, we will get the null matrix. But obviously remember that for this to be applicable, A and N must conform. If they do not conform, of course, we can't multiply them and we don't have a result. But just in case you guys want to check this out, we had A, which was how much? 7, 3, 2, 9. Okay, and suppose we have this null matrix of this. So AN gives us 7, 3, 2, 9 times 0, 0, 0, 0. And I mean, you guys can see, I mean, it's quite obvious that what we are going to have is 0. And if we do this, once again, this is what we get. So effectively, whenever we multiply, pre-multiply or post-multiply the null matrix with something else, we always end up with the null matrix itself. And that's the third type of matrix we're going to talk about. And finally, we come to idempotent matrix. Matrix. So an idempotent matrix, suppose B is an idempotent matrix. As a result, what that means is that if we multiply B with B, we are going to get B. And that is really what an idempotent matrix is that no matter how many times we multiply the matrix with itself, we always get the matrix. So as you can see, identity matrices are an example of an idempotent matrix, because if we multiply identity matrices with themselves, we get the matrix back. However, there can be other idempotent matrices. They're very rare. You won't come across them often, but there are other matrices which are not identity matrices that if you multiply with itself, you get the matrix back. Okay. So these are the 4 types of matrices we've talked about. And the reason we did that is we are going to see square matrix quite often. We are going to deal with identity matrix quite often. And it's good to know what a null matrix is. We won't be dealing with them a lot, but it's nice to know what they are. An idempotent matrix is just something important that, you know, it's interesting to know. So as long as you guys know this 4 types of matrices, you should be set for the rest of this chapter. So what we are going to do now is this is the end of this video right now. In the next video, I will be solving a few problems, simple problems with these 4 types of matrices, so that whatever confusion you guys have is cleared up.